Okay, good morning, everyone. Okay, questions? Okay. We will do some. Let me look at them. Okay, number 35. So we have to find.
Alexa.
Okay. So let's look at this problem. Usually when we have an integral, we have to get started of looking at it very carefully. What type of integrand we have? So the integrand here, it means the function we need to integrate is a rational function because it's a polynomial divided by a polynomial. And of course, substitution is nowhere inside. There is nowhere we can pick up a substitution because if I put u to be the denominator, I mean, the du is 3x squared minus 4. There is nowhere to be seen. And so we have to use the new technique we're developing that we call partial fraction decomposition. The idea that we did yesterday, the technique we use is called partial fraction decomposition. That's the name of the technique we are using. Partial fraction decomposition. All right, so the first thing we do is we look at the function and we look at the degree of the numerator and the denominator. The technique we're having work as long as the degree of the numerator is less. It will fail if the degree of the numerator is larger. So here the degree of the numerator is 2, the degree of the denominator is 3. So the idea of partial fraction decomposition works. And then let's see how it works. The first step in the process is to take the denominator and factor it out completely. I mean, totally factor it out. So we're going to factor out the denominator. This would become, to factor this out, it's x times x squared minus 4. This is not completely factored because x squared minus 4 could be factored further. So this will be x times x minus 2, x plus 2. So always, that's the first step in the process. Totally factor the denominator. Times x plus 2, okay? And then we're going to write this as the sum of simple function. That's where the word decomposition comes from. We're gonna decompose it into simple rational function if you want. And how does the composition work? It works like this. Each term here is what I called yesterday linear, and they are distinct. They are not different from each other. Right? The decomposition works like this. We're going to rewrite it as a over x plus b over x minus 2 plus c over x plus 2. And now we have to find a, b, and c. So the way we do, we're going to multiply across by the common denominator, which is x times x minus 2 times x plus 2. We should
I have
be
a question.
very, yes.
Doesn't matter which order you put in the.
No, absolutely
okay.
not. Absolutely.
All right.
Absolutely not. Yeah. The denominator, the common denominator, after you factor, after you decompose, the common denominator here should be exactly this one. So if you do something and realize the common denominator here, or the least common denominator, is not the one you have started with, you're doing something wrong. Okay. So now when we multiply, what will happen? I'm going to multiply this by that. Then I will be left with x squared plus 12x minus 4 equal. I'm going to multiply this. So only now I'm going to write it clearly, but then I will stop writing that. I will be left to x and the x simplify. I will be left with 8 times x minus 2, x plus 2. Plus, again, I will do the same thing here by the same thing. And the x minus 2 cancel out. I will have this times x plus 2 plus c times. Again, I will do exactly the same thing. And then the x plus 2 will simplify. I will have cx times x minus 2. And now we're going to reason along the following line. And we say, okay, I want this function to be equal to that for all x. If I want it to be equal to for all x, they should be equal for particular values of x. And we pick those particular values in a smart way. So which values we're going to pick? We're going to pick them so that somehow I can pull out the c immediately. So which value I should pick? In both sides. Anybody has a somehow understood what I said yesterday, how we pick the x's?
You can make x2 so that the
Yeah.
a's cancel out.
Right, that's the idea. We make x equal to 2, which will make this 0, will make this 0. So we're basically looking for the x that make x minus 2 0. And then I can pull out the b. So we want to put x equal to 2. And we have to be very careful. We have to put it both places. So here it will become a 4 plus the 24 minus 4 equal. This is 0. If I plug in x2 here, I will have b times 2 times 4 plus a 0. And that should help me to pick up the b off the back immediately. 4 and minus 4 will give me 0. So I will have 24 equal 8b, b equal to 3. I pull out by my b, okay? So the second value I pick, I hope you guys now saw the pattern, and I know that I've seen it. The second value I pick, what will make, what will make b 0? Sorry, what will make this term 0? 0 will make it, and minus 2. So I'm going to pick x to be 0. And I plug it back here. I will have 0 plus 0 minus 4 equal a times minus 2 times 2. Everything else is a 0. And this will give me a equal to 1 off the back. Okay. And finally, I take x to be minus 2. And this would give me 4 minus 24 minus 4 equal a times minus 2, and that's a 0. And that's a 0. Actually, I only want the c, and that's going to give me c times minus 2 times minus 4. And what will I end up with? 4 minus 4, 0. I will have minus 24 equal 8c. It means c would be minus 3.
I have a question.
Yes.
You said for A you had 2 options. No, for B you had 2 options to choose, either 0 or
Minus 2.
doesn't matter which one you choose, or they'll both give you the same answer.
I need to
both.
use both.
Oh, okay.
I used both. I needed both of them.
Oh, okay.
I need both of them. Okay.
Oh, okay. All right.
I did use both of them. So now what does this tell me? This tells me that my expression, it means this expression, that's really the benefit of that, this expression can be written as the sum of those simple stuff here. So it means a, which is 1 over x, plus b. 3 over what b was x minus 2 in my problem, plus c over x plus 2. Okay? So that's really what it tells me. So it's broke this function into the sum of simpler function. Not trivial, that's actually a very interesting approach. Now the question is, not the question, how, if you want to check your work, what do you think you can do?
Multiply the different smaller fractions that we got.
Start with the piece on the right, find a common denominator, and you should get exactly that. If you don't, what we're doing makes no sense. Because what we're saying that those are exactly the same. I start here from the right, find common denominator, I should get that. If you don't, it means it's wrong. Because these are the same thing, verbatim the same thing. It's just a way of decomposing them. Now the rest is integrating. So now that we wrote it as a simple stuff, now we have to integrate. So let us integrate. Okay, so I will have the antiderivative of x squared plus 12x minus 4 over x cubed minus 4x dx equal antiderivative of 1 over x dx plus 3 antiderivative of 1 over x minus 2 dx minus 3. 3 is a constant, that's why I'm actually getting it out, x plus 2 dx. Okay, and now we find the antiderivative. Okay, step by step. 1 over x dx, this ln of x, no problem, plus 3 is a constant. Now, from here to here, there is a substitution in order because I have an x minus 2. So we should do on the side, you guys should do 1 u equal x minus 2, a substitution. The du will be the dx in the simple scenario, and then I will have ln of u, it means ln of x minus 2, minus 3 times. Again, the same thing. If you want to do it correctly, because sometimes I will not have du equal dx, so we have to be careful. Again, u equal x plus 2, then I will have 1 over u du, it means ln of u, and this will give me ln of x plus 2, plus the constancy and of the problem. Okay.
I have a question. For simple antiderivatives, do we have to write out the work? Because, like, for example, if we do like cosine of 4x, it would be like 1/4 sine
Not
of
anymore.
4.
Not anymore. Not anymore.
Okay.
Not anymore. No, otherwise it will be tedious. But I want you to know them. I mean,
Mhm.
memorize them.
So, like, for this, we didn't have to put the u substitution.
No, but here what
Okay.
this one no, but what I'm afraid of, I tell you clearly what I am concerned about. Sometimes, and it's going to happen very soon, let us say the denominator is like that. Are you with me?
Mhm.
Is this ln of 2x plus 1?
No, because when you put the u equals 2x plus
Exactly.
1, you get 2, and then
Yes.
you'd have to divide.
Yeah.
Okay.
Yes, that's why I wanted to be careful. That's why I wanted to be careful. That's why I put it here in red and I did it orally. But when you have 2x plus 1, this is not going to work anymore. So you have to be careful what we're doing. Okay. All right, so let's look at the other two. I will 67. I will set it up. I will actually not solve it because I don't. So find the area of the region bounded by the curve. So we have a certain curve here. Line x equal minus 2, x equal to 2. So we have minus 2 and we have 2 and we have a certain curve. So I don't know exactly how it looks like, but it's bounded by the x-axis. So I don't have an issue here. And this is my function y. And we need to find this area. Okay, so that's usually using, and the function will have to be positive in this problem. I think it is positive. So the area is the integral from -2 to 2 of the function. Did anybody try to graph this? Yes, okay. So usually I should graph it, because if it does something weird like that, I'm in trouble. Okay. Did anybody try to graph it by any stretch of the imagination? So I'm gonna try to make sure that we're not gonna have anything that we don't want to. So I will graph it. So it is 1 over. Okay, I am actually graphing it because I don't want something wrong. Minus 24. Okay. All right. I'll share the screen with you so you see what kind of graph I have for 1 minute. So that's the graph, because I need to graph it. If I don't know what I'm working with. That's the graph of the function. So what do you realize the function looking like? So at -2 and at 2, that's why I graphed it, because I have to see what's happening. The graph seems to be something like that. Okay. All right, that's the graph. So what's going to be the area? So what I wrote that is not correct. Okay, what do you think is going to be the area? Is what I wrote here correct?
It's the opposite of what you wrote, right?
Exactly, because I did not graph it, but I couldn't go on without graphing. So basically, because if we follow the approach we're doing, if I take this to be my slice, the top curve, so here, the top curve is 0, and the bottom curve is the 10 over x squared minus 2x minus 4. So what the area is going to be is actually, if you want, it's 0 minus that. 0 minus this. Which it means it's going to be minus the integral from -2 to 2 of 10 over x squared minus 2x minus 24 dx. Okay, so we have to graph, because what I wasn't expecting it to be totally negative. I was afraid we have something like that. And then we have to break it, the positive part and the negative part. But it turned out to be all negative. So the top curve is 0, the bottom curve is this one. All right. So now the question is basically integrating. And integration, that's a typical scenario where substitution absolutely failed. That's a rational function. So we have to use partial fraction decomposition. Step 1 in the process is we have to totally factor out the 24 and the 2. What are the factors here? 12 and 2?
Like -6 and x plus 4.
6 and 4. Okay. So x plus 4. All right. And the rest is actually simple. We can rewrite it as a over x minus 6 plus b over x plus 4. Okay, and then I multiply across. By the common denominator. And I will get 10 equal a times. Okay, if I multiply a by that, the x minus 6 will go, x plus 4 plus b. I have to multiply this term by x minus, by this expression, and I will be left with x minus 6. And now immediately, that's a simple scenario. I can take x to be minus 4. This will give me 10 equal minus 10b, b equal negative 1. And then I take x equals 6. Give me 10 equal 6 minus 6 is a 0, 10a, a equal to 1. And we're basically done at this stage. Then I will have my expression 10 over x squared minus 2x minus 4 can be written as my a, which is a 1, over x minus 6. My b is x plus 4. So the area is minus the integral from minus 2 to 2 of 1 over x minus 6 dx. Actually, I can do it all at once. Minus 1 over x plus 4 dx. So it's equal to minus. Now again, like in the previous problem, I'm still dealing with a denominator, x minus 6. So even if I put u to be x minus 6, the du will be the dx. And I will have ln of x minus 6. So there's still a simple scenario here. Minus ln of x plus 4. The whole thing evaluated between minus 2 and 2. And finally, I will get minus. Okay, at 2, I will have ln 2 minus 6. You see here where the absolute value start playing a role. 2 minus 6 here is a minus 4, but because I have the absolute value, it's the ln of 4 minus the ln of 6 minus, at minus 2, I'm going to have ln of okay, at 2, where am I here? Okay, I will have minus 2 ln of 8 minus ln of minus 2 plus 4 ln of 2. The rest is just math. Okay. Okay, questions before I go on? All right, we look at the last one. I may not finish it, but at least I will start you. Number 77. Okay, so we have the following integral. Ex over ex minus 1, ex plus 2. Okay, quickly, how do we do this problem?
Let u equal e to the x.
Exactly. We have to let u equal e to the x. It's just basically screaming at me, telling me, you know, you have to put u equal e to the x. Because if I put u equal e to the x, I will have u minus 1, u plus 2. I will go back to the previous situation. So it's like a mix of two strategies. So we're going to start with a substitution. We have to start with that. Will give me du equal ex dx. Okay. And then this would become the integral of u over u minus 1, u plus 2. And this would become, sorry, nonsense. 1 over that. And the rest, I think by now you should be able to do it. That's a simple integral, a over u minus 1 plus b over u plus 2, and then the ends of that. Okay, so the idea is we have to start with a substitution to get rid of the ex, and then we proceed. Because partial fraction decomposition only works when you have a rational function. This is not a rational function. Because rational function, it means the denominator has to be polynomial. That's not a polynomial, and that's not a polynomial. So I cannot use it unless I write it as a term of a rational function. There are a lot of restrictions on when we can use this approach. Okay, any questions? Okay, so today, I mean, we're going to stay with this section for a while because there are a lot of cases that we have to take into account. So we're going to do another one today, another case. So yesterday, the case we took was the case where the denominator, when we factor it completely, all the factors are linear and not repeating. So today we're going to take the case, the following situation. So I think I called it sub case yesterday. Okay, all right, the denominator, after it's totally factored, is a product of linear factor that can be repeated. That's the new idea. And I explained that can be repeated. Okay. So suppose the denominator is a product of linear factor that can be repeated. And the question is always the degree of the numerator less than the degree of the denominator. We're always working under this condition. All right. And how the decomposition would work? I would explain it by examples instead of giving you all the symbolism that we should. So how does the decomposition work? First, what does it mean? Linear factor that repeat. So it means something like this. Suppose you take the denominator, you decompose it, all right? Sorry, you factor it. And you get something like 2x plus 1 squared times x minus 4. And let's see the denominator. I'm just making up stuff. Let's see the denominator is x plus 2. Okay, so that's really my function f after I totally factor the denominator. And how the decomposition work? All right. Both are linear. Linear, it means the power of x is 1. It's not, there is no x square in the picture. Okay, that's what linear means. Repeating, it means this is linear because there is no x square. It's of the form ax plus b. But it's repeating because they have a power of 2. And then how do we decompose? The decomposition works like this. The contribution of the term, the linear term that do not repeat, is like before, a over x minus 4. That's for the term that do not repeat. For the term that do repeat, its contribution will be 2 pieces. One piece is the 2x plus 1. The second piece would be the 2x plus 1 squared. That's how the decomposition will work. Okay, so the term that does not repeat is like before, a over x minus 4. The term that repeat, that its contribution to the decomposition is b over 2x plus 1 plus c over 2x plus 1 squared. Okay, I will take another example just to basically to really understand what does it mean. The idea is that if the term repeat itself 3 times, it's gonna come up here 3 times. So I will take another example to show you what I'm saying. So suppose f of x equal x, I don't know, x plus 6 divided by. So I'm gonna exaggerate a little bit to show you the picture. X cubed, x minus 4 to the power 3, x plus 2. So I'm exaggerating, but to show you the picture. Let me put this 4, exaggerate a lot. All right, analyze the denominator. What do we have here? x4, we can think this as a linear because x is linear, but repeated to the power 4. X minus 4 is linear, repeated 3 times. X plus 2 is linear, non-repeating. So the decomposition will work like that, equal to. The non-linear term, sorry, the non-repeating term, its contribution is fairly simple, a over x plus 2. The question are the repeated one. X to the 4 is repeated 4 times. So the contribution is going to be b over x, c over x squared, as many times as it repeats E over X4. That will be its contribution to decomposition. Now, this term repeats 3 times, its contribution will be 3. So E will be have F over X minus 4 plus over X minus 4 square plus H over X minus 4 to the power 3. So of course, I gave a huge problem just to emphasize how this approach will be. That's how the decomposition will be. So this will be repeated 4 times because X4, and this 3 will be its contribution in 3 terms. X minus 4 square, X minus 4 to the power 3. Okay? And the rest is exactly like we did before. So we're going to take an example to elaborate this idea. Questions? All right. So we're going to take 2 examples, and I think this would do for this case. So find the following antiderivative. Integral of 4x squared plus 1 divided by x to the power 3 plus x squared dx. Okay. So again, that's a typical rational function, and the degree of the numerator is less than the degree of the denominator. Substitution is off the table because even if I put u equal x cubed plus x squared, the derivative is 3x squared plus 2x, nowhere to be seen. So we are going to use what we call partial fraction decomposition. That's the name of the technique. So the partial fraction decomposition tells me step 1, you have, sorry, that's square. You have to totally factor out the denominator. So you factor it out till you can't do that. So here, x squared, I can factor out x plus 1. Now we decompose. Okay, we have x squared and x plus 1. This is the linear, simple, not repeating. Its contribution is a over x plus 1. As I said, the order in which you write it, it doesn't really matter. X squared is repeating. Its contribution is b over x plus c over x squared. And now we do what we did before. So we're going to multiply across by what?
Denominator.
Which is?
X squared times x plus 1.
X squared times x plus 1. Okay, and see what we have. We have to do it very carefully. That is, they shouldn't do mistakes at this stage. So let's do it very carefully here. I'm going to multiply this by x squared times x plus 1. This will give me 4x squared plus 1 equal. This term has to be multiplied by x squared times x plus 1. So this would give me ax squared plus. This will be multiplied by x squared over x plus 1. X simplified, I will be left with bx times x plus 1 plus. This one again, multiplied by x squared times x plus 1. X squared cancel each other out. I will have c times x plus 1. So this has to be done very carefully. And now I'm going to do exactly what I did before. And this problem, I will use it to show you 2 ways of finding the coefficients. A, B, C are called coefficients. To find the coefficients A, B, and C. First, we will do it exactly the way we have been doing it before. All right, so I have to pick the values of x's, which will somehow make some terms be 0. So I can pick up a coefficient that I want. So which values of x will do here?
0 works.
0 works because 0 will make this term 0. It will make this term 0. And then I can pull out my c. So x equal to 0 will give me, plug in 0 here, I get a 1. This is 0, plus is 0, plus is c. So I get my c equal to 1 of the back. Okay, now another value of x which will do.
-1.
Negative 1. Negative 1 will make this term 0. That's what I'm after, and will make this term 0. X equal -1. And then I will have -1 squared here. So I will have 4 plus 1, that's a 5, equal a times -1 squared, and is 0 and is 0. So this would give me my a equal to 5. Okay. Now, is there any other value of s? So I still need, so I have my a, and I have my c. I need a b. Okay. So is there any more value of x which will make this term 0 or this term 0? So I can pull out my b.
No, I don't think so. Can you plug those back in?
If I plug 0, 0 will make this term 0, but I've already took it into consideration. -1, so I'm actually don't have any. So how I'm gonna pull the b?
Put your C and your A back in, so 1 and 5,
I plug it back in and then,
and then solve for B.
or wanna find an easier way. This
Could
equality,
you
go ahead.
could you have a x squared plus c x plus 1 and then equal to bx squared? Like, could you have the a part plus the c part to equal to b part?
I don't think I follow.
So like just have a x squared plus c x plus 1 equal bx x plus 1, and
No,
then
how,
just
what happened to 4x squared plus 1?
oh no, okay.
Okay, all right. Anybody have any idea? Okay, the thing is that this equality hold, this mathematics was going on. We want this to be true for all x's. We said, okay, if it's true for all x, it's true for 0, it's true for -1. But it's true for all x's, so I can pick any x I want to pull out my b. It doesn't have to be 0 and -1. 0 and -1 are the convenient value, because 0 and -1, 0 will help me to get rid, to make this term 0, pick up my c, and -1 did that for me. But the idea is not, you don't have to take 0 and -1. 0 and -1 are the smart choices. Any value of x, you can plug it in both sides. So to pull a b, I'm going to pick any other value of x, plug it here and plug it here, and pull out the b, because I know I have the a and the c by now. So any value of x you want, which value you want, and I say any value you want, you can plug it in, and this
2.
equality will hold. You can pick x equal 2, but because I'm lazier than you, I'm going to pick x equal 1. I'm picking something fairly easy, so the math will be easy. You can pick 2, you can pick 100, you can pick anything you want. You will pull out the b, we will all have the same value. So suppose I pick x to be 1, I will have 5. I just picked it 1 because 1 is an easy number, equal to a, but I know what my a is now. 5 times 1 squared plus b times 1 times 2 plus c is 1 times x plus 1, 2. And now I use this to pull my b. So you can pick anything you want to pull your b. So I will have 5 equal 5 plus 2b plus 2. The 5 and 5 cancel each other. I will have 2b equal -2, b equal -1. Okay, and that's really the idea. The idea is that you can pick any x, plug it in both equations. We pick first the one that makes the most sense, the easy one, and now I can pick actually any other values to build out my b. And now this is what tell me. So now I will have the following, that my expression, which is fairly complicated, very hard to integrate, is equal to a, which is a 5, over x plus 1 plus b. B is plus c, 1 over x squared. And now we're going to integrate. The antiderivative of that equal antiderivative of each term. That's 5 times the integral of 1 over x plus 1 dx minus 1 over x dx plus, this is 1 over x squared. 1 over x squared, we have to be careful with it. That's x minus 2. That's not a natural log antiderivative anymore because I have the square here. So finally, I will have 5 ln of x plus 1 minus ln of x. 1 over minus 2 plus 1, which is minus 1, x to the minus 2 plus 1 plus my constant c. Okay, so the term we have to be careful with now is 1 over x squared. That's not, the antiderivative is not an ln term, because once we do those, we kind of fall into the trap. Everything is ln, and this is not the case. And this is going to be minus 1 over x. Okay. Questions? All right, now there is another way to find the constant a, b, and c. Okay, and that's the approach the book uses, but sometimes that approach is actually way harder than the one I'm using here. But I will have to talk about it because sometimes it's easier, and it will be a matter of choice when do we use it. So another way to find the coefficients a, b, and c. So that's what I'm going to use this problem to introduce the other way. So another way to find the coefficients a, b, and c. Coefficients, though we call those coefficients a, b, and c. So I will use the same problem to find it. So we had 4x squared plus 1 over x squared times x plus 1. And we broke this, we decompose it into this term. So the beginning is verbatim the same, nothing changes. Then the same thing, we multiplied across by the common denominator, x squared times x squared plus 1. And this gave me ax squared plus bx times x plus 1 plus c times x plus 1. Okay, and as I said, another way to do it is absolutely another way. All right. The way it works is like this. We're going to distribute here. Plus bx times x give me bx squared plus bx plus cx plus c. Okay, we're going to totally distribute. And then we will do the follow. We're going to rewrite this as basically a polynomial here. So it means we're going to put everything, coefficient of x squared together, everything in x together, and the constant term together. So x squared, I will have a plus b. And for x, I will have b plus c. And for this one, equal to c. And this side is 4x squared plus 1. Okay? And then we proceed as follows. We say that I want those two functions to be the same. And the only way this can happen is if the coefficient of x squared here equal to the coefficient of x squared here. So for this equality to hold, I need the a plus b to be equal to 4. Then I need the coefficient of x to the right to be equal to the coefficient of x to the left. But here, there is no coefficient of x. So the way you can think about it is that the coefficient of x here is basically a 0 because we don't have one. I mean, so I want b plus c to be equal to 0. Then I want the constant term here to be equal to the constant term here, which is equal to 1. Okay? So to find A, B, C, using this approach will boil down to solve basically a system of 3 equations, 1, 2, 3, with 3 unknowns, A, B, and C. So solving this system, sometimes it could be very hard. So the approach I'd use would be way easier, and sometimes it will not be. So this would work. So let us solve this. So I get C equal to 1 of the back here. And this is going to give me B equal minus C, means B equal minus 1. And we should definitely get the same answers. And finally here, A plus B equal to 4. It means A will be equal to 4 minus B. But B is minus 1. Give me A equal to 5. Okay. All right, so that's really the other approach to this problem. So first approach is plug in specific value of x's, and then this will solve the problem for me. The second approach is basically rewrite this expression clearly as a polynomial in degree 2. That's what we did actually. And then we say, okay, coefficient of x squared here coincide with that. That's how the equality will hold. Coefficient of x here will coincide with the coefficient of x here, but I had a 0 and then the constant term. So this is an absolutely different way of finding the coefficient. Which one to use really depend on the problem at hand. In some problems, the way we've done it is way easier. In some problem, this is going to be slightly easier than that. Okay? Questions? Any questions? Okay, so I'll finish with a slight problem along the same line, a little bit. Okay, suppose I do that, at least I get started and you guys can finish it. Something 2x minus 1 square on the x. Okay, again, integrate that. All right, so we are in the same situation, partial fraction decomposition. Degree is 1, the degree is 3 here. So we have to decompose it. Equal. Right. Linear, non-repeating, plus linear repeating, means it has to show up twice. 1 with the 2x minus 1 and 1 to x minus 1 squared. Now again, we multiply across by the common denominator. This one. Okay. And this would give me x minus 2 equal. If I multiply, I will have a times 2x minus 1 squared plus b. So this will, one of them will go, one of power of the 2x minus 1 will go. I will have x minus 1. And c, I will have x minus 1. Okay. All right. Now we're going to find a, b, and c. And I'm going to find it using the first approach. You guys can do it the second approach. Which value of x shall I take?
1.
1. Balls will go away. So I will have 1 minus 2 equal a times 2 minus 1, right? Plus 0 plus 0. A is minus 1. Immediately. What's the other value you want me to take? Please, all of you try to pitch in. You can
What about half?
That will be a perfect value. Because a half will make this term, this expression 0. It will make this expression is 0. I will pull my c off the back immediately. So it's going to give me a half minus 2. We should not be scared from fractions a lot. That's going to give me a 0 here. That's going to give me a 0 here. And here I will have a half minus 1. So I will get a minus 3 half equal a half minus a half c. So this will give me c equal minus 3. End of that. Okay, what the other value you want?
Why would it be -3 and not +3?
Because I do stupid mistakes. Okay, what's the other value? Because I still need b.
1.
1? You can
Yeah.
No, I did that already.
Oh, I thought we could just pick anything from Harrison.
But we did. We cannot take it twice.
Oh, okay.
You could do
I-
0. Maybe.
I took it
Negative
already.
1.
What?
Negative
I can
1.
take negative 1 will do. That will do. Or 0 will do. But not 1 and 1/2 because I already took them. You want negative 1? I go with negative 1. I will have -1, -2, -3 equal a times. Now I have a. I just substitute a by what it is. So I have it. Then I will have -2. I will have -3 squared. It's the b that I don't know. So if I get -1, if I am doing it, I will put x equals 0. I think x equals 0 would be easier, but it doesn't really matter. X equal, I'll have -2, I'll have -3 in here. -1, -1, -2 in here. Plus c times -2. So we get -3 equal, that's 9, -9, minus, it's a plus, 2 times 3, it's a 6, 6b. And sorry, 3 is 6, c is 3, so I will have -6. So this would give me -9 minus 6, that's a -15. -15, it's 15 minus 3 equal to 12. I will get b equal to 2. Okay, as I said, you can take x equals 0. You will get b equal to 2. Regardless what you take, you will gonna get b equal to 2. And now 2 minutes and we'll finalize this problem. So it really looked a hard integral. I mean, it looked very hard as the beginning, but now we can finalize it. So now this is going to give me that x minus 2 over equal to a, my a is -1 over x minus 1, b, 2 over 2x minus 1, and my c is 3 over 2x minus 1 squared. Again, you want to check, take the expression on the right, find a common denominator, you should get the expression on the left. That's what it is. So we are just decomposing into simple terms to be able to integrate. And now the antiderivative. So the antiderivative will be equal to -1 over x minus 1 dx plus 2 times antiderivative of that plus 3 times the antiderivative of this expression. Okay. And now one we have to be careful. This is minus ln x minus 1, because if we put u equal x minus 1, the du will be the dx. So I am safe in here. This one I have 2x minus 1. Then I have to be careful. I cannot put ln of 2x minus 1. Okay, so this one and this one we have to isolate. Okay, I put u to be 2x minus 1. Du is 2 dx. So this we have to be careful with, because the du is not the dx. So it's going to give me a half 1 over u du. It means a half ln of 2x minus 1. Okay, So this will gonna give me a 2 times a half. Now, by coincidence, I had 2 here, but I could have had any other numbers. So the reason they cancel is because I have 2 here. ln of 2x minus 1 plus. This one also had to be totally isolated and done by itself because I have an inside function. So now I will do this. Again, my u will be 2x minus 1. My du dx. And then I will have a half u minus 2 du. It means minus 1 over 2. Okay, and then I am done. I will have minus 1 over 2x minus 1 plus and of the problem. Right? As usual, I am after time. Okay, please do your homework for tomorrow and you guys have your quiz and everything will be on Brightspace. All right, have a good day. Bye-bye, guys. Anybody has any question?